All right, welcome back. I hope you had a great lunch. Right before lunch, we had a talk from James about how applications crash in the wild. Rust is a programming language that is designed to eliminate a whole class of issue that would lead to a crash at runtime already at compile time. So it's obviously a very nice thing to have for a developer. Now I have the pleasure of introducing my two colleagues at KDAB, Andrew and Leon, who will be talking about marrying Rust with Qt. Give it away, guys.
Hello, friends and enemies. I see the usual troublemakers are evenly distributed around the room, so feel free to interject if we're not making any sense. So I'm Andrew, and I'm with Leon today. What are we going to talk about today? We're going to talk about memory-related bugs. So if we look at security trackers of CVEs, 70% of the issues from CVEs in Chromium were memory-related. So whether this is using null pointers or double free or whatever it is. Same Apple and Microsoft across their CVEs, again, 70%. Maybe this is only for a few companies, but Firefox, another 70-odd%. A lot of us have mobile devices these days, walking around, could have random devices nearby to us, trying to connect to us. The Android Bluetooth media stack, more than 90% of the CVEs are related to memory safety. So why do all these large corporations that have lots of money, lots of tooling, some of these decade-old projects still have these issues?
Right, and the reason for that is actually because it's very simple to do. And we just have some very basic C++ code here. And so what it's doing is simply it's adding something to a vector until it has the correct size. Then we remove some of those values again, especially we're removing the even values here so that we only end up with the odd values. Doesn't really matter what we're doing. And we then print those values. And would anyone like to take a guess at what the output's going to be? I bet you $20 you cannot character by character give me the correct output. Anyone want to take me up on that bet? No? Because the output is actually that. That's what I got. And would you just notice that very lovely segmentation fault in the end that's just casually thrown in there? So how did that happen? That looks like completely reasonable C++ code. And if I were to ask my compiler what he thinks of that, Andrew?
Looks good to me.
Good to me. Compiles without warning on a default CMake installation. So how did this happen? Well, we made a simple mistake. This here is a pointer. You probably haven't noticed, but it's a const char pointer. So if we add a value to it, we actually jump in memory to random addresses, which can then corrupt their output and may segfault the application, but only after it's printed 10 lines of garbage. So what if we fix that? What if we replace that with the correct stream operator? Well, we actually get a list of numbers, so that's good. I've removed the value part. It's not really adding anything. But I can't remember pushing that number here. Like, how did that end up? And also, didn't I remove half the values? So why do I still have 20 numbers there? So that's really, really odd. And well, that's because it's really simple to introduce these memory-related issues in C++. We can have undefined behavior simply by pushing back on a vector because we're actually also iterating on it, which you may not have noticed. And also, that remove if actually doesn't remove anything. It just moves stuff to the front. You might have encountered that already, but it's actually bitten me twice in production code, so that's a bit of a problem. So then we're proposing Rust as the solution for that. But Andrew, can you tell us why would Rust help us with any of that?
Well, if we change this code to Rust code, this would be the equivalent Rust code. We've still got the vector creation. We're still pushing to it until we get to 20. We're then retaining the values we want, and then we're going to print them. So let's ask the Rust compiler. What does he think of this?
Well, no, let's just not.
So let's look at the first issue that occurs. So the first issue we get is more a syntax one. We can't print like we were, so it's sort of a simple one to fix. The macro is written differently. So let's fix that issue. And then let's ask the compiler again.
Well, that's better. At least you're not having garbage syntax there, but your program still isn't correct. I can see you're doing something invalid there.
Do you want to explain that for me?
Yeah, so that's kind of the thing. Like you probably know your GCC and Clang error messages, how they tend to be like dumps of data with a few lines that are actually relevant. So in Rust, I'm just going to go ahead and tell you, like, this is where your problem is, and this is where it's coming from, because those two things are actually related, and I'm going to like actually show you the file as well. We stripped out some more useful information because it was a bit too much to have all the links that it also gives you to relevant resources there as well. But yeah, hopefully that could help you fix the problem.
Looks much better than my C++ compiler errors. So our code doesn't work, but it's failing at compile time rather than runtime, which is perfect. Now the developer knows they need to fix it, and we can't ship it, and the end user doesn't end up with it. So let's move on to fixing this code. So what Rust has forced us to do, we can't mutate the immutable vector while we're iterating over it. So we can create a second vector, push to that vector, then extend it back into the other one, and obviously we fix the print line. So let's ask the compiler again.
That looks good. I think we're fine.
What do we think the output will be? Nice?
I think so, yeah. I mean, it's compiling, right?
We've got sane output. So was that a much better developer experience? So how does this work?
Yeah, because it's great if it does work, but we also need to know how. So there are multiple concepts that Rust introduces that are actually already available in C++, but they're only in your heads most of the time. But Rust really makes them explicit. They're nothing really new, but they're something that we now have to actually express in our code. For example, ownership. In this example, we have one string, and then we assign that string to another one. Instead of within C++ where it's copied, we're actually transferring ownership here. We want to actually say, okay, S2 is now the thing that owns that particular string. And if we try to print that, well, the compiler complains about it, because we're trying to print the original string, which is S1, but we've moved it away, so it doesn't exist anymore. And the compiler knows because it's tracked that move. And then the same thing goes for, okay, if everyone needs to own something, then we also need to be able to borrow it. This is kind of what we're doing here with the reference. We're creating a reference to a value, but unfortunately that value is only inside that scope. So X owns it, and we're borrowing it so that we can also use it. But then we go out of scope, and we still try to print that reference. That's something that could easily happen in C++. But again, in Rust, because we actually have made that ownership explicit, like X must be the owner of that thing, and it knows where that ownership ends, it can also know that that reference is no longer valid. And then again, it gives us a very helpful message that shows us all the steps involved. This is where it breaks, this is where our ownership ends, and that's where we try to borrow it. And the same goes for any other kind of undefined behavior that you might have due to memory-related problems, like uninitialized variables. You'll just get a plain error message. You can't do that. There's nothing here that's valid. You have to give it a value. So if we just sum up what we get by that, we get memory safety by default, which can help with a lot of the stuff that James has told us about today. So maybe we can spare you the Sentry setup next time around, even though it was supposedly very helpful. But we also get safe and easy multi-threading, because we always know that there's one person that owns a specific thing. And so you can't actually have data races, because you simply cannot write to the same thing at the same time. Also, the templating system, in this case it's called generics. It's based on traits, which makes it much more safe than the C++ equivalent, and also gives you much better error messages. You also get package manager by default, which means easy dependency management, but you also get the same bare metal performance. There's no runtime overhead, no nothing. This is still compiling down to x86 assembly without garbage collection, without anything. Because it's all relying on compile time abstractions, which is then where you kind of pay the cost with slightly increased compile times. And if you're interested, I can highly recommend you check out the Rust book that will explain all of this in detail. So then, Andrew, we've established that Rust is a really cool language, but where do you think it would be useful together with Qt?
It's an interesting point. So if we look at a typical Qt application, if we start at the bottom, you have some form of state, whether that's a database, whether that's sensors or something on a car, or whatever it is, the state of the thing you're changing. Then you have an abstraction layer above it of maybe list models and things. Then you might have proxies or adapters or controllers that might help you modify that list model a bit. And then you have some views and maybe some shared components, and that might be widgets or QML or whatever. These layers we can simplify a little bit. So we have a presentation layer, we have some business logic, and we have some data at the bottom doing something. So which of these layers would we be good for? If it ain't broke, don't fix it. So Qt's a established framework, handles a lot of things for us, you know, multi-touch, touch, mouse, keyboard, different platforms and everything. There's a lot of history with it working around issues, drivers, whatever. So for the presentation layer, QML or widgets, still easy to use, very fast, iterative, decorative in QML's case. So we think Qt's still useful in that layer for now. There's not really any established UI frameworks built from scratch in Rust yet. So it'd be still useful to use Qt, and we all have a lot of knowledge invested in Qt, and a lot of companies' money and training, whatever. So where would Rust be useful? Probably in the business logic and data layers. Why would that be? Well, Rust is very good at parsing unsafe inputs because it's memory safety, and a lot of the macros and things can allow very easy syntax for parsing like JSON or whatever. You can do safe multi-threading, and then that allows you to do very performant data accumulation with the ownership. So your business logic could be all in the background thread, not affecting the GUI, and will be very performant and safe, and you know it's not going to have any major issues. So Leon, what existing bindings exist for Qt and Rust?
So possibly unsurprisingly, because Qt is such an important library, there are already existing solutions out there. And we'll just take a quick look at each of them so that you know your options, basically. So first up, there's straight up, I don't care about safety. I'll just go with Ritual, or sometimes also called Rust Qt, which can give me all the things from Qt, and because it basically exposes the entire API from Qt over to Rust. That does, however, of course, have the problem that because Qt, from Rust's perspective, is inherently unsafe, and it's also object-oriented, which Rust actually isn't, we result in very non-idiomatic code in Rust, and we basically lose a lot of the safety guarantees that we've worked so hard to gain with Rust. But on the other hand, you do get all the access, basically, to Qt. But if we don't want all that unsafe code right there to use, we could also consider QMeta Object RS, which represents QObjects with a safe Rust API that allows you to basically declare your own QObjects in Rust, and is then targeted especially to expose them to QML. It also uses Rust's build system directly, so if you want to have a fully Rust stack, that might be your best option there. However, for the FFI, it does use the CPP crate, which basically means you can write C++ right within Rust code, and that's, of course, again, very unsafe. And because it's using the internal QMeta object API, it also contains a lot of Qt version-specific code, because that API does change quite a bit with Qt versions. Then we also have the Rust Qt binding generator, which tries to, rather than simply exposing Rust directly from Qt, tries to create a bridge that's more data-driven. So you define your data that you want to transfer between Rust and Qt more explicitly. However, you have to do that in JSON, which can lead to a bit of a boilerplate situation. But it then does allow you to give you a safe Rust API, and it also uses CMake, so it's easier to integrate into existing builds, and then calls cargo internally. However, it also uses an unsafe way of then interacting with Qt internally. Whilst it wraps the API for you, it still internally uses unsafe extern C, and basically then does direct calls, which, whilst they might argue, yes, they've authored that code for you, well, we can see that 70% of the bugs are still memory related. So yes, that's a good argument, but only for 70% of the time, or 30% of the time, rather. So to sum up, why would or maybe would you not use what's already out there? Well, rituals, of course, is already unsafe, so only use it if you really need all that access. Qmeter object-rs directly embeds C++ code into Rust, so I wouldn't count on its safety as much. And it also doesn't really allow you to expose those Q objects to C++ as easily. It's mostly meant for QML. And with Rust Qt binding generator, we end up with a lot of handwritten JSON, which means lots of boilerplate, and it still uses the unsafe extern FFI internally. And if we just take a quick look at the code, on the left we have QMeta object-rs, and for some of you who might be familiar with Rust, you can see that it's not really idiomatic at all, because we have, for example, methods defined within structs, which is not how Rust does it. Rust splits it up into a struct and an external implementation for it. And you also have a lot of the Qt peculiarities just kind of shining through with, for example, here that you have that read notify syntax again, which you might not even be familiar with as a Rust developer. And if we then look at what it looks like if you actually implement that code, you also still have to call the change signals on all the properties if you modify them. So you have to remember that, which technically is also kind of unsafe from a Rust perspective, because it's not really defined what happens if you just forget to emit the signal. And with the Rust binding generator, we also see that we just end up with a lot of code, and these are basically doing the same thing in our example here. Which then brings us to one of the newer libraries that can actually give you safe C++ FFI, which is exactly what we need, and which is what Andrew can tell you more about.
Yes, so there's this new crate, or library as they call them in Rust, which provides safe Rust and C++ interop. It uses then static asserts on the C++ side to check that the types are what the Rust expects, so it's all still compile time fun. It doesn't have any copying, serialization, memory allocation, runtime checks as things are going across the bridge, so it's very, very performant, and it's intentionally restrictive and opinionated, which means you can't sort of do bad things. You can only pass things across the bridge in certain ways, like via unique pointers or things, which then means the ownership's been moved, and you can sort of guarantee things are going to work. That's their documentation page. It's very good to look at. Great documentation. So is anyone already using this? Well, CXX is used everywhere at Facebook, in production at huge scale, by the way. And also in Android. You remember that Bluetooth for media issue earlier with the 90%? Well, parts of that might be changing over to Rust soon. So how does that work? Well, you define a bridge, which is a description of the boundary at the top. It uses macros. Then if we go down the right-hand side, it uses code generation to then generate C++ bindings, which then end up as idiomatic, normal, straightforward C++ code that you can just include as normal, put it in your CMake, do whatever. Then if we go down the left-hand side, it uses macro expansion for the Rust bindings, which then ends up as normal Rust code. And in the middle, it uses a hidden C ABI. So what would it look like if we just try to wrap parts of QColor in this. So we define this bridge here. We include where the type's coming from. Then we declare the type. And to define methods, because obviously Qt's in C++ with classes, so with Rust we don't have classes. So you tag the self onto the type, so then the method is on that type, and we implement a unique pointer for it. It says unsafe up there, but the actual generated code ends up being completely safe from an API point of view. It's just syntax. So what is CXX? It makes the Rust code feel like Rust and the C++ feel like C++. Basically means we keep it idiomatic on both sides. We don't have just direct bindings that, we're in another language and it just feels like the original language. We want it to feel native for the language we're writing in.
Which then brings us seamlessly to CXX-Qt, which is our addition to that whole ecosystem, which is basically to add support for Q objects to CXX, because CXX can already wrap C++, right? We can already define a Q color for use in Rust. But what we really want to also do is integrate with Qt's object system, because that's what it's all built upon. And like we mentioned earlier, Rust doesn't have objects really with inheritance and that sort of stuff. So how can we add that? Well, with CXX-Qt. And just like CXX, it works in a very similar fashion. You have a QObject description that has a macro at the top, and that description in itself is valid Rust syntax, so no JSON bindings that you have to remember how to write those, and you can also use the existing Rust tooling, which then ends up in, again, code generation for the Qt or C++ side, which generates just a normal QObject subclass as a sort of wrapper around whatever you want to do in Rust. And we then, on the Rust side, have a macro expansion that can give you a struct that contains all the data that you need on the Rust side and all the code that you might want to execute. And we then assure safe interoperation between the two using CXX to then bridge our methods across. And CXX will then make sure that we have a safe FFI there. So if we look at the typical anatomy of a Qt object, these are kind of the things that we really need to define with CXX-Qt that we also couldn't do earlier with CXX. First things first is, of course, a base class. At the moment, we only support a QObject as the base class, but that is subject to change. So at the moment, you just write make a QObject for me, but that might change to something that actually has the base class in it, so that you can, for example, create your own dist models from inside Rust. And then within that module that defines your QObject, you can then, just like with normal C++, you can define properties. However, this time you'll notice that this is really, that looks like Rust, right? That basically is Rust. It even uses Rust types like I32, which are then going to be transferred over to the corresponding Qt type once we do the generation of the C++ code. And anything you basically define in here is going to end up in C++ as a property. Then we can also define methods, which in this case we'll do in an implementation for a struct that's called the Rust object, which is basically your code and your data that lives completely in Rust, that doesn't know about properties, doesn't have to, but it's your kind of gateway into Rust. And there you can define invocables, for example, but you can also mix in non-invocables if you want to have functions that are only available from Rust. And there you can just write your normal Rust code, and we will automatically wrap that for you so that it's safe to call from Qt, and we will also transfer over the correct type names and everything so that that will just work out. With signals, that's actually something that might be a bit strange to C++ developers, because here we're using an enum, and that enum actually declares all our signals at once. So we actually have two signals here, one that's ready, which doesn't have any arguments, and another one that says whether our data changed. And interestingly enough, what you can do in Rust is you can actually have enums that have values in them. but you'll only be able to access these values if the enum is actually of the correct value. Because otherwise, the syntax actually just doesn't allow you to get to that number if your signal is actually ready. You just can't have that. And that way you can define all your signals very easily. And then, as the last piece of the puzzle, we can also define private state and private code on our Rust object. We can have any Rust data. It doesn't need to be transferred to C++ or anything. This is just normal Rust code. And you can also use, for example, these traits, which in this case would generate the default value that your Rust object is going to have when you actually construct your Q object from C++. And after all, this looks like a very short example, and it really is, and it even has more stuff in it than what we showed earlier with QMetaObject.rs and the Rust Qt binding generator. This uses signals that we also declare and a lot of private state. But it's very concise, looks like Rust code. It basically is Rust code, and it's all enabled by that make QObject macro at the top, which is really a new way of kind of expressing macros in Rust, which hasn't been around when QMetaObject.rs or the binding generator were created. And then how do we use our QObject, right? We just created a QObject. I want to see it in action. And it's actually really simple. We generate C++ code for you, right? So just include your file, register your type with QML, and you're good to go. You can just instantiate your QObject. You can, for example, also have normal property bindings, because it's, again, just a normal C++ class. You can bind, for example, your string to your number and call methods if a button is clicked, and it will just seamlessly work. And an interesting tidbit you may have also noticed is that we're also transferring the snake case of Rust to camel case, just because that's the default in C++, and we want to be at home in both worlds. So to sum up, CXX-Qt is built on top of CXX, and it can, in the end, give you idiomatic code on both the C++ and Rust side. It uses macros to generate bindings, so no JSON that you need to write. It already comes with the library of the common Qt types, so that QColor that you saw earlier that will be available to you as well. And we also provide some mechanisms to make threading safer, to safely update, for example, from a background Rust thread, because you will need to get back into the Qt thread at some point. However, like CXX, we are more opinionated. We will not let you shoot your own foot, if it were. But that also means we can't give you all of Qt, but we can let you extend Qt in a way that might be helpful to you, especially if you have an existing large application. And Andrew, as our sort of main architect, is going to take you under the hood and show you all the cool details.
So the first thing to look at is ownership. So obviously ownership in Rust needs to be strong. So when we create the Q object, we create that on the C++ side, whether that's from QML or you can create it via Rust, we have a way. But basically, C++ then owns that Rust object. It's then a member in that Q object. Then your methods or invocables live on the Rust side, private state, and your signals are declared there. At the moment, we've got the properties actually live on the C++ side, maybe subject to change later, but we'll see. And the base class is obviously defined on that side. If we look at some of the existing solutions we explored earlier, they don't necessarily keep the multi-threaded safety that you might expect. So if you write multi-threaded C++ code like this, so at the top we just have an invocable that's on the Rust side, on the bottom we have C++ code that's using the thread pool, and it calls the same method twice at the same time. And if you look on the right side, we start from one thread, and then we also start from the other thread. So it means we're acting on Rust code at the same time, which isn't safe from a Rust perspective. So we need to be very careful with multi-threaded code going across the boundary, and Rust should not talk directly to Qt. We should only have sort of going back around the event loop. And and multi-threaded Qt should only talk to Rust one at a time. Otherwise, the guarantees on the Rust side are going to be broken. It's sort of, the Rust compiler doesn't know what C++ is going to do, so we need to protect against that. The last one's easy to protect against. The middle one's a bit trickier. So if we go to the middle one, the way that we handle sort of synchronizing your state from the Rust side back to Qt is we use what we call an update requester. Rust has this other concept called channels, where you can send data to and receive data. So in your background Rust thread, you can then send new data to it, and then you can request an update or a synchronization to Qt. That puts an event on the event loop, waits for that to come around, and then from the GUI thread, then it's calling back across to Rust so we can synchronize safely and then continue. So that allows us to then do multi-threaded Rust without breaking guarantees on the Qt side as well. So, Leon, where are we currently and where are we going to go in the future?
So, at the moment, CXX-Qt is especially suited if you want to move an existing application to Rust. So if you want to step-by-step start with maybe a single Q object that you might want to try out, how does it look in Rust, how does it feel, does it behave well? And also especially because of that step-by-step approach, it's very suitable for large existing existing projects. Because we hook into the CMake ecosystem, you can just integrate that in CMake as normal C++ code, because that's what we generate. And then you just link to Rust as a static library, and it's all there. We also recommend that you actually have a clear data boundary between Rust and Qt. If you just want to randomly throw stuff over to Rust and then get results back, that's really not what CXX-Qt is meant for. And because we're that opinionated about what we allow you to do, you'll probably also find it very hard to do. And one of the biggest strengths as well is that with CXX-Qt, because we actively want to support you being able to still write C++ code, you can integrate C++ and Rust ecosystems pretty seamlessly. So if you still need your own old C++ libraries because they're not yet available in Rust, you can still use them, no problem, and possibly declare your own boundaries for those with CXX, or use CXX-Qt to talk to them, depending on what you need to do. And the current state is that we're still very much in the early phases of all of this. All the code that you saw does compile, it does run, but that's also basically all we have at the moment, which is we can do a QObject subclass, and we can do all the important things, which is properties, invocables, and signals. We also have a library for most basic QML types, so you can access your string, your color, and your date time, and whatever basic type you might need, as well as the aforementioned threading helpers that make it so that you can accidentally shoot yourself from multiple Qt threads and have Rust be all unhappy about it. So that then also brings us to what do we still need? Well, we most importantly need a way to inherit from other Qt base classes. We have something as a model worked out for that already. We just haven't implemented it yet. But that would then allow you to, for example, write your own item models, so your own list models, and integrate with more of the existing API. We also want to, of course, wrap more of the Qt types so that basically as much of Qt as you might need is available to you, even from Rust. Also, we want to bring our way of writing these sort of FFI bridges closer to how CXX does it, so that you can more easily mix and match CXX with CXX-Qt, and you could then even do that from within the exact same module. And of course, we need to stabilize our API. We're still in the learning phase of how exactly all of this should ideally play out. So we need to stabilize how the macros work, and of course expand documentation, tutorials, and examples, even though we already have quite a few of those. but all of that means the API is still subject to change. What you saw now was working, but it might look slightly different in a few months' time. And that already brings us to the end of our presentation. We have a demo set up downstairs, so come visit us there after the talk. We also heartily invite you to look at our GitHub. You can clone it, you can build it, you can run it, and especially on GitHub, we'd really appreciate any feedback, any ideas that you have, and especially give us an idea of what you want to do with Rust in your Qt application. What do you need to be safer than it has been before? And of course, if you have any questions, ask away.
Thanks a lot, Andrew and Leon, for the talk. I'm sure you will have many questions. I should not have said that.
Do you plan any interaction with the QObject ownership tree? Just like as far away from Rust ownership model as you can get, I guess.
Well, basically because we're just exposing a new QObject to you, you can, of course, already handle all that stuff from C++ or ideally from QML, so you can just reparent within QML, that's no problem. Doesn't matter, like our code doesn't really care about that. You can just reparent it as you wish. We don't yet have plans to kind of expose that functionality to you from Rust, but you could, for example, also mix that in with rituals, bindings, or if we see that it's a common need, then we'll, of course, integrate it.
So from the tool chain perspective, how would it look like when I would develop for an embedded device? So what is actually downloading what and what is integrating what? So is this like Rust is kind of, I'm using cargo, Rust, like the package manager, and it's downloading compiler for me for CXX so it fits together? Or am I still free on the compiler? Can it work with any compiler?
Well, so the way it works is it's a normal CMake project, and then we have CMake code which then calls through to Cargo, and you'd normally have a Rust compiler installed in your machine, and with that you can install, Rust has a tool called RustUp, and you can then use that to download different tool chains. So a lot of different architectures and boards already have a tool chain, or we even got Yocto to build one for us. And then it still uses LLVM.
I think for the demo we have downstairs, we are actually using GCC for the C++ code, and then Clang for Cargo, but it really doesn't matter too much because in the end you're building your Rust code and your C++ code completely separately. You're just linking them to each other in the end. Yeah. So we don't restrict your C++ tool chain, and we don't restrict your Rust tool chain, basically.
If no one else, over there.
I'm not familiar with Rust at all, so maybe the question is not relevant at all, but how does it look like when you are debugging the application? Is it possible to follow step by step Rust side and C++ side?
Yep. So you could put a breakpoint in the Rust invocable, and when you hit it from QML, you get the full stack trace, and it appears like a normal C++ application. With VS Code, you just need the LLDB, which just helps it figure out the symbols and things for the Rust side, and then it's just like normal GCC debugging, not a GDB debug.
I have a question for you. Jesper's not here, I think, but he likes to mention how proxy models like to crash. Will Rust fix this?
Maybe. I mean, we're not yet at the point where we can inherit from other classes, but as soon as you can inherit from other classes, we can also provide proxy models and possibly make them safe as well.
What is actually stopping you from doing that? Why is it complicated to inherit from other classes? And can you access the API that QObject has? Can you already access that from the Rust side as well?
So you've got the problem of an object-oriented language. Rust isn't, so how do you describe that on the Rust side? And then you have other things like virtual methods. How do we say that we want to override that? And then we don't necessarily want to one-to-one map some things. Like maybe we could avoid some of the detail of Qt in the way if you implement a list model, there's quite a lot of boilerplate in that. So maybe we can provide some helpers with that. But you could use CXX underneath to provide you all the methods you want and effectively override them. I think we'll add some syntax to allow you to override a method from the base class. So you could just arbitrary methods to implement any class.
And a big part of the reason is just that we haven't gotten around to it yet. So we have to kind of mostly do a lot of thinking of how should the Rust syntax look like. But once we figure that out, it's just a case of instead of generating, it's inheriting from public QObject, we just inherit from public QAbstractItem and then we're kind of done. We need to figure out how do we declare something as virtual or an override, and that's basically the problem at the moment.
There's sort of no technical reason why it wouldn't work eventually, so it's maybe in the next presentation you'll find out.
Another one from me. So what you're providing is the ability to basically bridge a QObject of your choice towards the C++ side. Do you ship any sort of bindings for types in the standard library or in Qt?
So in the Qt standard library or the C++ standard library?
Or stuff like exposing a specific class from the Qt library to Rust?
Yeah, of course. So basically the basic QML types that we mentioned. So for example, the QColor that you saw, that's actually from our library. So you will be able to just use QColor as if it were a normal Rust object as well.
That's something to look at further as well.
Yeah.
With the arbitrary CXX usage, then we could allow you to expose custom C++ classes across to the Rust side, as well as defining new QObjects in the Rust side and exposing to C++. So we want to be able to do both.
Anyone else? Don't be shy.
So you mentioned that you envision this being used in porting. Why limit it to that? Why wouldn't you use this for building a new application?
If you're building it from scratch as a Rust developer, without C++ knowledge, then Qt is not necessarily good for you. Like, I think if you were to use Qt, you probably need some C++ knowledge, and you need to use the tooling like CMake and things. If you're building from scratch with Rust, they aren't quite there yet, but there are other toolkits you can use, like Slint and things that are getting bigger and better. They're not at the Qt level yet, but so we feel that if you were a group of C++ developers, you would still mix and match a bit. You wouldn't write it from scratch in Rust, and we can't make the whole Qt framework native to Rust either, so we have to bridge it. I think you're ultimately always going to have something on the C++ side doing something. There'll be something odd or use case that you just can't
But if I, as already a Qt developer, wanted to dip my toes into doing my data processing in Rust,
exactly,
that would still be a good use case? Or?
That's pretty much exactly the use case. It's what they call oxidization. So,
and that's also why here in the second point we actually say that it's good for projects with a large amount of QML and C++ knowledge, not necessarily code base. So, like you said, you have a lot of QML and C++ knowledge. So then, yes, CXX-Qt might be right for you, even for a new project. But we're just kind of focusing our efforts at the moment more into step-by-step ports. So maybe you might run into something that we didn't expect, but we'll be happy to fix that as well. It's nothing really stopping you.
And it's about you being able to use both ecosystems. Like there's a load of libraries on the Rust side that are cool and everything, but they don't have everything. And maybe there's still some C++ libraries you want to use. So you might want to mix and match in your application.
All right. If there are no further questions, then thank you, Leon and Andrew, again for this Q&A.